make state-of-the-art algorithms discoverable and accessible to everyone. So take all those cool models that folks have built out there, put them up in a way that other folks can get to them, can utilize them, can build on top of each other's models. And I'll talk a little bit about that later on. But I work here as a full-stack developer and a technical advocate. If at any point you want to chat, please feel free to email me, jpeck@algorithmia.com, or Peck John on just about every social media out there. So what I'm going to talk about today is this concept of productionizing your models, which may or may not be a phrase that you've heard, but quite likely the state that you're at right now, if you're earlier on, is that you may have just a few models. You may be working in just a few languages and frameworks, perhaps scikit-learn, perhaps TensorFlow, perhaps a few other interesting ones. Let me get this out of the way here for you. Okay. You are probably running on your own dedicated hardware or possibly VM hosting. Maybe you've spun up an EC2 instance to both train and then actually run the predictions on your model. Or if you're really lucky, you might actually have an IT team that's helping you out and doing all of those DevOps, managing servers for you. But in a lot of cases, it ends up being just your job or just the job of the data science team to get their own stuff out there. This results, generally speaking, in a fairly high time to deploy because you're taking time away from the other important things you want to do, finding new data, training new models, etc. And so it can take a few hours or it can take a few days, in some cases a few weeks, until you get around to actually deploying out new trained models for other people to use. And then when you do, often those are manually discoverable. There's not always an index of what's available. So you're letting people know, hey, go to this server, use this port, use these authentication credentials, etc. And that slows down the speed at which you can work and the speed at which you can get your models out into the world in a useful way. That works for as long as you've got just a few end users and you don't have too many models yet. Often there's heterogeneous APIs between those different models you're putting out there, unless you're synchronizing really well across your team. And then pretty soon that starts to blow up. So you go from having just a few models to having tens or hundreds or even thousands of different models across your team and spanning many different languages and frameworks. As your team grows, you see different patterns of coding and usage of those models. And while some of those models might be used just once a week, others may be used thousands of times per second. So this puts a really high DevOps load on your team, and your IT department has to work really hard to make sure that your models are always available for anybody who's using them. Furthermore, you're going to eventually see the need to auto-deploy, where as soon as you change a model and put it out there, someone else can immediately use it. Better discoverability, where there are indexes or ways of finding all the models that are out there and how they can be used and what they do with good documentation. You're going to want to decrease your latency so people can use those in really high volume environments. And you'd really like to have a common API across all of those models so that people don't have to read very heavily each API of each different model and spend a lot of time learning how to use them. You'd like it to be common across all of those. You'd like them to be composable so you can pipe output from one model to another and have them work together. And you'd like to have some kind of fine-grained security model around it so that you can say that different customers, different users in your different teams, et cetera, are allowed to use or see different types of models that you've got out there. So what about the user interface itself, too? So initially, when you build a model, you're often just creating that, you're saving your trained model, you're providing it out to other people, and maybe you provide them a script where they can just run it locally if they have the right requirements already on their machine. Sometimes you go and you build your own basic UI. That might be a desktop app of some sort, or it might be a fairly simple web page that's integrated into your server. But of course, what that integration does, if it's just, say, a page that goes and runs the model underneath it and returns results into a web page, means that's not reusable very easily. You can't have other applications coming in and using your model directly. They've all got to go through this web page interface. So the best way that we've seen to deploy a model out there in the world so that it really is usable from everywhere is to do it as an API, which is to say that you're going to take that model and you're going to wrap it up in a JSON API interface. So some program or script somewhere out there can simply say, hey, this is the input I want to send into that model in a nice JSON data structure. Now, JSON is usable from just about every language in the world, so anybody can go out there and they can just use that model directly from whatever language you want. Once someone's actually gone and they've hit that model, they're going to get some output, and that's going to be whatever result happens to be returned from your model itself, okay? So this is a simple hello world example, obviously, but your model would be doing something more complex. It'd be sending in, a whole set of time series data over that JSON call, and then getting back some set of, predictions or locations of anomalies in that data as a structured result. Once you've done that, and you have this interoperable JSON interface to that model, then people can start building their own desktop apps. They can start building their own Android app. They can start building their own web pages. You can even service-to-service connections so that other automated utilities, such as, say, logging or monitoring, can be utilizing your model in their service itself without there being another specialized UI or interaction just for that. It gives you the ability to separate, if you want as well, the UX development even within your own group out of the data science team. So if you don't want to spend a lot of your time building web pages, building user interfaces, as soon as you've got a nice documented API out there for interacting with your model, you can just hand that off to the user experience development team. And they can build whatever interfaces they want to that and deal with all of the user concerns having to do with the user interface, leaving you to do your job as a data scientist, going out and doing all of the cool model building that you do. So let's take a look at some examples of how these are actually used out in the real world right now. We have an algorithm called sentiment analysis, pretty straightforward. It takes a English language statement and it evaluates it as positive or negative. And it says, hey, on a score of -1 to 1, how like angry, mean, nasty was the statement, up to how happy, great, affirmative was the statement. We took an off-the-shelf bot tool. We happen to use RunDexter, which has its own fairly simple script language. And you can see right in the middle of that, we were able to simply insert a post statement out to that API for our sentiment analysis algorithm. And all that sentiment analysis does is it takes a document object, which is just any abstract text, and it returns back a number, which is the sentiment. So fairly simple user interface. The script that it's run from, the actual chat script, doesn't care anything about what's happening under the hood on the server. It just knows that it sends a document and it gets back fairly quickly a number, which says, hey, how good or bad was that statement? So then what the chat developer is able to do is they're able to build their standard basic chat interaction. If someone says, hey, what are our hours? It says back, oh, we're open Monday to Friday, 8 a.m. to 9 p.m. And then if the user says, hey, those are terrible hours, that script is able to now detect that as a really negative sentiment and say, oh, geez, I'm not doing a good job. I should shunt them to some other pathway. And instead of just spitting back a standardized response based on, say, what keywords are in there, it can now say, oh, hey, it looks like I'm not doing a good job. Maybe I should get you over to a human. Maybe I should have somebody call you because they could do a better job. So now that script is able to take advantage of whatever machine learning capabilities you've implemented up on your server. But the actual script creator doesn't have to know anything about machine learning languages, frameworks rather. It doesn't know how to integrate that into their own script. They just are making an API call. Very simple for them. Here's another real world example. If you go to bit.ly/sheets-AI, you'll find there a Google Sheet which you can clone. And that has in it the ability to fire up a plugin built into Google Sheets, which then talks to Algorithmia and runs any of our machine learning algorithms that are out there. Obviously, you could build this with any other system. We happen to build it with ours, of course. And what this does is it gives the power to run all of those machine learning models right into the hands of a high-level manager, a business guy, someone who doesn't themselves do anything with machine learning. They just want to be able to use it. But now right in their spreadsheet, they can click on a cell and they can say, hey, run the email address validator, or run sentiment analysis, or run keyword extraction on that cell and give me back some results. So now from their point of view, they're doing something very, very powerful inside a Google spreadsheet. And from your point of view, you've put out these models that do different things, and they're being automatically integrated into that user's workflow and making their lives better. I also want to show off some fun demos for you. So if you go to demos.algorithmia.com, which I will do over here, you'll see a bunch of, these are just simple web pages. They're HTML, CSS, JavaScript, things I've built over the years, just to kind of show off what you can do with a few simple lines of JavaScript once you have an API out there that you're running, right? So colorize a photo. There's a model out there. It's seen lots and lots of different black and white and color versions of images. When I hand it a novel black and white image, it's going to try to colorize that based on what it's seen before and send that back. So does an okay job. There's a little bit of not quite guessing right around the edges here up near the tops of the snow peaks and a little bit of graying down here, but on the whole, pretty good, right? But from the point of view of the web page itself, all it's doing is making a JavaScript remote API call, right? It's just saying at some point in the script, hey, I've got this image, send this image to this remote endpoint, gets back a colorized version of the image, displays it for the user. Takes about 4 lines of JavaScript inside the page itself to do that. But behind the scenes, there's this really high-powered deep learning model that's running up on the server, which has been spun up just in time to respond to that call and handed back an image so that we can use it. And then just as a further demonstration of where you can go with this, not that this is where you're going to necessarily start out, but if you write, say, another little API endpoint, which will take a video and split it into all of its individual frames. Each of the individual frames is, of course, just an image. Then, once you have those APIs out there, and if you've added scalability so that you can automatically get as many copies of that server as you need running, you can process all those images in parallel. So I can send a black and white video, and I can run it through colorization, and it's going to take that whole black and white video, split it into frames which are parallel colorized on different servers, and then all the results are combined back into a colorized video. Now there's some color flicker and that sort of stuff I would want to fix up after the fact, but it demonstrates the power of once you have these in APIs and you have them scalable, you can do some really, really powerful things very quickly, because once again, that's only about 4 or 5 lines of JavaScript to make that set of calls from this actual web page. The rest of the JavaScript there is just handling layout and interaction and that sort of thing. So there's a lot of other demos there. You can go and you can play with them if you want at demos.algorithmia.com. But let's get back to the actual meat of our content here. So what are your options for how you can actually deploy the models? You've got a model, you've trained it up with whatever framework, you've done all your hyperparameter optimization, and you've got this model file now, and you want to put it out there in the world and actually have people able to use it. Might be the general public, might be some part of your team. So unfortunately, the biggest way to actually distribute these right now is GitHub, right? Which puts a lot of load on the end user. You've put your model out there, you've put your code samples out there, you've put some sample data out there, but they've got to pull that all down. They've got to build it locally. The user has to be a developer. You can't just have a naive user going out and doing this. No matter how good your scripts are, there's going to be quirks in their environment setup and that sort of thing, what kind of GPUs they have, all that kind of stuff. So generally speaking, if you put your stuff out on GitHub, you're always going to need a developer to pull that down and build it locally, right? Plus, you're giving away your code and you're giving away your trained model. Now, that may be cool if what you're doing is open source, great. But if you're working in a sort of corporate where there's IP issues, then it's going to be a real problem, you putting that stuff out there like that. And so for this reason, when you're working within a company, generally speaking, we're only using hosted repositories in this way, or copying model files around within the company itself. And once you've done that, you're, of course, dealing with local execution. So the actual run of that model depends on the machine specific, the CPU, the GPU, how much memory they've got available. And it's limited to the power of that one machine. So you can't do things like, say, cluster with just a local machine. Of course, that doesn't work, right? So whatever the specs are of that machine, that's what you're stuck with. So that's the simplest way of deploying, is simply copy your stuff up where somebody else can grab it. Of course, you'd want to go a little further than that, right? The next evolution of this is, generally speaking, to set up a server. Now, that might be setting up your own physical server that you're running somewhere. It might be renting an entire machine, but most of the time nowadays, that's basically spinning up a cloud VM. So something like an EC2 instance on Amazon, for example. So what you do, you pick the right CPU, the right GPU characteristics, frameworks, the right amount of memory for your particular model, whatever it happens to need. That first configuration can be a little bit painful. You got to get all your right frameworks on there. You've got to get things working properly. You've got to install CUDA, etc. But once you've got that initial script for setup done, it's not that hard to replicate. If, for instance, you're using EC2, all of those virtual machine instances that you grab, if you're grabbing the same type, those are all going to be basically identical from the point of view of your setup script. So once you get something like Ansible running well on one of them, you can just replicate that to as many different servers as you need. Okay, pretty good. But unfortunately, this also does get expensive for higher powered machines. So if you're building your own, that's often thousands and thousands of dollars to buy, especially if you're doing GPU enabled serving. And if you're renting from EC2, it can cost anywhere from $1 to $10 an hour per machine for GPU-enabled EC2 instances. Now, if you're only doing one machine ever and your load is pretty low, that's great. But as soon as you start, that it's very expensive very fast, because you've got to have enough machines out there and running to be able to satisfy your peak load, the maximum number of users you might have at any time, right? All right, so you've set up your server, you've got that running, you've got your core frameworks in place, and then you've got to build a microservice on top of it. Normally, this is just firing up something like Flask if you're dealing with a Python model, and building a simple API wrapper. If you're interested in doing that, I highly recommend going to slideshare.net and checking out /Jeff Klukas. Sorry, I can't pronounce his name right, but the link is there on the right-hand side of this slide. And he's got a whole description of how they, at Simple, set up their own machine model flow with Flask and how you can do that kind of setup. Once you've done that, you've got an API, right? So it's usable, as we discussed, from any language, any environment. That's great. Though you still have the considerations of how are you going to build security around that? How are you going to meter its usage if you need to limit certain people to a certain rate of usage? How are you going to disseminate that? How are you going to tell people about it, et cetera? And then lastly, you're going to need to worry about scaling, right? So again, if you're dealing with that one server, low usage, great. But as soon as you get hundreds of people using it, or if you yourself are using it a lot, like 10 or 100 times per minute, if it's some kind of high volume predictor, that server is going to start to choke. And what you're going to need to do is you're going to need to scale out more servers, and you're going to need to put out some kind of load balancer in front of them, right? If it's your own servers, obviously that's really painful. You've got to buy more hardware. You've got to build more interaction between them. If you're using something like EC2, it's not so bad. You can just spin up more cloud VMs, but you've got to have that automation for knowing how many you should have, predicting the load, putting the load balancers in front of it, that sort of thing. So it's possible, but it does get a little bit painful. Now, some of you may have heard the term serverless floating around a lot. And to me, that's really the next evolution of where almost all hosting is going to go. Serverless, if you haven't come across it yet, obviously there's still servers on the back end. It simply refers to the idea that you don't have to deal with any of the DevOps. You don't have to be concerned with specific servers or anything like that. That's all handled by the provider. And the big three, they all provide their own different versions of serverless. Amazon's got Lambda. Google has its cloud functions. There's Microsoft Azure cloud functions as well. So these are pretty cool. You go in there, you say, hey, I want to make a function. And you just fill out a function body. That function body can do whatever you want. It can load up scikit-learn. It can deserialize your model from wherever it's stored. It can run whatever variables come in from the user into it, get a prediction out, and just return them. You're not worrying about serializing and deserializing JSON. That's all handled by the provider. So the API wrappers around it that are usually in place. From your point of view, all you're writing is a function that takes an object and returns an object, and you're done. From the end user's point of view, that's represented as an API. They send in JSON, it runs your function, they get back a result, and they're done. Simple, no one has to worry about managing servers. And the scaling is instant and it's elastic. So as more and more people come in and start using your server, using your particular function, they're going to see many parallel execute that spinning up as needed. They're not even thinking about it. Generally, there's almost no latency on the user end. And basically, just more and more copies of your functions are going to get spread out and run across many servers on the provider's end. And when then they're not in use anymore, that's going to collapse back down, so nothing's running at all. And what's cool about that is you get basically billed per compute second. So lots and lots of people using your function all at the same time, lots of copies out there, you're getting billed for all of those copies. Nobody's using it all, you're not getting billed for anything. There's no sort of payment to keep a particular server live or anything like that. So this is really cool. But there are some very significant limitations when it comes to using machine learning with these systems, because they're really not optimized for ML. They're more meant for general application development. That's where they grew out of. So there's, generally speaking, support for Node across the board, and some of them have Python, Java, or more rarely C#, but that's about where the language support ends. And you're going to be tied into whichever provider supports that one language that you actually want to run. They generally have a hard cap of 5 minutes of execution time. Now, for smaller models, that's not a big deal, right? If you're just doing, simple time series prediction on a small amount of data, okay, great. But as soon as you start getting into your higher powered deep learning models where you're doing lots of image recognition or you're chaining models together, that 5 minute execution limit can become a problem for certain predictions. And perhaps most importantly, there's no GPU support on any of these systems. So if you're running a deep learning model, you're going to have to run that in CPU mode. And that means it's going to run a lot slower and be a lot more expensive because you can't take advantage of GPUs. They're just not available in these serverless systems. So that takes me to the thing that we've built having seen this problem, which is Algorithmia, which is basically serverless functions that have been optimized for machine learning. So you've got all those same benefits of serverless that I just mentioned. You've got that simple setup. You just fill out a function body. You get automatic API wrappers. You're just taking an object and sending it back. You're not doing any DevOps. You're not worrying about how many machines are running or their characteristics or anything like that. You just basically tell us, hey, this is my function name. I need it to be GPU enabled. I want it to be closed source, and here's the function body. And that's it. And again, your build per compute second. Things are scaled automatically. So nobody's running it at all. You're not paying. Lots and lots of people are running it. That's the cost is for all of those simultaneous copies at that point in time. That said, it's still fairly cheap because you're just paying by the compute second. Now, what we've done is we've taken that same serverless model and we've taken away a lot of those drawbacks. We've optimized it for machine learning. So we support Java, JavaScript, Node.js, Python 2 and Python 3, as well as R, Ruby, Rust, and Scala. So you can pretty much pick your language and throw it in there. We've got a 50-minute execution maximum. So if you are running a really big deep learning model, hey, you can run that for up to 50 minutes before returning a prediction. And we're going to keep that running for you. And most importantly, we've got GPU support. So now you can take those GPU-enabled TensorFlow models, you can throw them up there, and they're going to take advantage of all that great NVIDIA GPU acceleration. Perfect. On top of this, we've layered a marketplace as well. So you do have the option of simply taking your model, putting it up on the server, and keeping it completely private. Only you can see it, only you can run it. And we have a lot of people that do that because it's the one model they've built for their one application that they're building, and they don't really want to share it with anyone else. And that's fine. Totally support that. Love it when people do that. But what we really think is awesome is when people make a model that's going to be usable by lots of different people and then decide to share it to make it publicly available. And what that means is not that you're making the model file itself available. If you don't want anyone to, then nobody can see your code, nobody can see your trained model file. You're simply saying, hey, I'm going to make execution of this publicly available. So anybody else can come in and they can run that model and get back a prediction. And what's cool about that is you can do it in a way where you actually get a royalty back if you want to. So you can take your model, you can throw it out there, you can say, hey, anybody else is allowed to use it. And every time anyone runs it, I want to get back a 10 credit royalty. And so anytime anyone executes, that royalty goes into your account, and when you reach a certain amount, you can cash that out. So we see this as a way of motivating machine learning developers to create models that are generally usable by lots of people, and then put them out there, and then also get paid for their time that they spent developing it. And the other cool thing about this is that unlike other serverless function models where the person who creates it and puts it out there is the one who's always paying for its execution, the way we've set it up is that the person who's executing it, the person who's calling the model, is the one who's paying. So if you put a model out there and you make it publicly available, set a royalty or don't, whatever you want, and then you never yourself run it, you're not going to pay anything. It's the other people coming in and executing your model and using it. They're the ones that are paying for that execution time. So what this does is it creates a big dynamic marketplace where lots of people are putting different models out there that each of them can use, and they can build much bigger, stronger pipelines of cool stuff by using each other's models and building really big pipeline systems. So I want to walk you through what it actually looks like to deploy a model as a serverless microservice with Algorithmia so that you can get some actual hands-on experience with this. And if you go through this, then at the end of the day, you're going to have your model out there and live and working as an API. And it's only going to take you a few minutes to a few hours, depending on how complex your model is. For most people, I find the deploy time is less than 15 minutes. So once again, we're a platform for machine learning that can use Java, JavaScript, Python, R, Ruby, Rust, or Scala. So any model in any framework that uses one of those languages, you're probably going to be able to put it out there on us. You're going to get GPU acceleration, 15 millisecond total overhead, and a 50-minute limit per function call. Yours, if you make it public, will join the other 6,000 microservices that are out there in the marketplace. So people will be able to locate it, people will be able to use it, and there's going to be a common syntax across all of those. And if you happen to be, I'll just throw this in here, I'm not really going to focus on it, but if you happen to work in an organization that needs a private cloud deployment or on-premise deployment of that same system, that is something we support. We call it our enterprise AI layer. And what that allows you to do is then put basically the whole system you're about to see and put it inside your own private cloud so that only your company has access to any of that, and you can really lock everything down. You can even air gap it if desired. So I'm not going to focus on that, but if you do want to talk with any of our guys about that, just send an email to sales@algorithmia.com. All right, enough said about that. To get you spun up with this, open up a web browser. You can do this now, or you can copy it down later. I'll give this code again at the end of the webinar. But if you go to algorithmia.com and use the promo code NEXTCON18, that's going to give you $50 free in your account to play with as much as you want. And this is going to give you the power to both, put up and test your own models a whole lot, or to go out and just look in the marketplace and use other people's models and see what they do. When you do hit that join button, quick note, down at the bottom of that screen, there's a promo code drop down. Make sure you hit that drop down to get the space where you can fill in that code, NEXTCON18. Okay, that's at algorithmia.com. Once you've done that, and I'm going to talk through this fairly quickly, but then I'm going to give you a link to a repository which actually has all of these steps and some demo models so that if you wanted to, you can try it on your own. Once you've done that, you're going to find yourself on the screen that shows you the marketplace, shows you all the models that are already out there. So there's a getting started section and explore, but then you can also click around and see our featured algorithms and that sort of thing. And pick other ones to play with. I'll talk about what those look like in a minute. But for now, in the upper right, you're just going to hit that plus, and that allows you to create a new algorithm. All of these have their own namespace, so you can name your algorithm whatever you want. It's going to be underneath your username, so there's never going to be a collision. So, I may have a car detector algorithm, and Bob may have a car detector algorithm, and mine's going to be JPEG/car detector, and his is going to be Bob/car detector. Cool. So I fill in whatever name I want. I pick the language I want to write in. I choose whether or not to make this open source or closed source. Either one is fine. Just depends on whether you want other people to be able to read your code. Again, that doesn't necessarily give them access to the model file. It just gives them the ability to see your code, which in many cases is going to be fairly simple. It's going to be get the model file, deserialize it, run a prediction, right? Decide what options you want below. So you can say, hey, this algorithm needs to be able to go out and access the internet at large. For example, you're making an object detector where people might want to paste in a public URL of an image. Turn that on. If you want it to be able to call other algorithms, that's the next option. So one cool thing here is that you can have your algorithm utilizing other people's models as well as your own. So, out there, I may build, say, a general object detector. And one of the things object detector finds is cars, right? Someone already out there has a car make and model detector, which, given that it's being sent a photo of a car, will tell you the make, model, and year of the car in that photo. So I can enhance the capabilities of my object detector by, in my code, after I do my object detection, if I see one of the things there is a car, I can then take that image and I can send it to the car make and model detector and get back a response from that saying, what's the car make, model, and year? And I'll just then take that result, put its results into my own output from my algorithm. And now I'm not only telling the user, hey, there's a car and a person and a stop sign in this image. I'm saying, hey, there's a 2012 Ferrari and a person and a stop sign in this image. So I can use that pipelining capability to really enhance the capabilities of my own algorithms. And then lastly, I pick whether or not I want advanced GPU. So if you're not using a GPU-enabled model, please use standard execution environment. It'll use less horsepower and be easier all around, and your model will run faster. If you are using GPU enabled, pick advanced GPU there, and that's going to accelerate your algorithm. Once I've done that, I hit create algorithm. And then I've got my options. There is a Git repo created for each one. So I can Git clone that down and use whatever IDE I want. Great. But for the time being, I'm actually just going to fire up the Algorithmia web IDE, which is built right into our system because the code I'm going to be showing here is really, really simple, right? So I click on that web IDE option, and I get an IDE here that I can code on right on the web. For the time being, I'm just going to put in this simple hello world. Now, normally what I would have at the beginning is, I'd be doing something like import scikit-learn, and then I would load my model file right outside the apply function so that it's statically available and I don't have to reload it each time someone comes in and calls it. And then inside my apply function, I would actually take that model file, run my prediction against it, and then return the result. But for the time being, I'm just going to go with a simple hello world, right? Once I've written my code out, I can hit the compile button in the upper right. And obviously, Python's not a compiled language, but what the compile button does in that context is it simply stores it into our servers and makes the algorithm ready to run. Once I've hit that compile button, it'll chug for a second, and then it'll say, okay, here you go, it's ready. And then down at the bottom, I have a console where I can actually try executing that algorithm. So I can type in some input, and it's going to give me back a response. I'll iterate through this a few times, adjusting my algorithm in whatever way I need, retesting the input, and when I'm satisfied with it and I think it's ready to go, I hit the publish button in the upper right. Once I hit publish, I get to choose, hey, is this going to be public where anybody can call and go ahead and run it? Or is it going to be private where I'm the only one who's allowed to run it or even know that it exists? I can set pricing. That's where I set that royalty if I want to be paid back when other people call it. I can set my versioning number. And then I go ahead and I publish it out to the real world. Now, once I've hit publish, this is where that discoverability and documentation component comes in, right? Because when I hit publish, if I've made this algorithm public, it goes out and it creates a page just for my algorithm where I can fill in a description at the top. I can tell people what it does. There's even a docs tab at the top there where I can fill in a very complicated, if I want, very long description of exactly what the algorithm does, its inputs and outputs, maybe even the research behind it. I also get down at the bottom a run an example box. And what this does is it allows visitors to come in and they want to test out this model before they decide to actually start using it in their code. They can just type some input there, hit the run example button, and it actually fires up my model and gives back a result. So people can try it out right there and see what it looks like. Then, scrolling down to the bottom of the page, I actually get code samples in a bunch of different languages. So curl, if you just want to test it quickly from your console, maybe I'm running a web page, there's going to be a cut and paste JavaScript example there. Maybe I'm running it from Python, there's going to be a cut and paste Python example there, right? So this is super powerful. Going into Algorithmia itself and clicking on, say, the marketplace, I can see all of these algorithms are out here and they're categorized. I can look at just text analysis ones or, just say computer vision ones. They're tagged, they're rated, so other people can actually rate and comment on models as they come in and see which they like best. But if I go into any one of these, like say sentiment analysis again, I got what I just showed you. I can actually go and I can run this and I can get back some results. But if I scroll down here, I've got this cut and paste Python that's ready to go. And I'll just demonstrate for you that this actually works by just copying this Python right here, heading over to a Python console. and simply pasting that right in. So we can say I import the Algorithmia. This is just pip install Algorithmia, by the way, just to pull down the Algorithmia wrappers. Again, everything's a JSON API, so I could just call it from REST, but importing Algorithmia makes it possible for me to use this syntax, which is really easy, where I generate my input document, I start up an instance of the Algorithmia client, I tell it which algorithm I'm going to run, and I could iterate on this using lots of different algorithms, one after the other. And then I just simply pipe my input into that algorithm. So very simple. I'm going to actually do that. And there we go. I get back a response. I can see my initial document that I passed in there echoed back to me. I can see the sentiment value is moderately positive. And I also get some metadata, like how long it actually executed for. You can see that ran very, very fast, right? So there you go. That's what other people are going to see when you actually go and you publish out your algorithm. It's going to be findable in that index. It's going to be searchable. They can test it out. They can copy the code down into their own code samples and immediately start using your model. All right. So if you do want to go and try running your own, this repo is out here, and it's even got a pre-trained model in there. It's not a very good pre-trained model, I will tell you that right now. It's a very simple example. But going out to bit.ly/algodev, ALGODEV, I've placed a repo here. If you click to digit recognition, the README in here will describe all of the things you need to do step by step. You simply download the pickled model from this repository. You go in and you drop it into your hosted data area in Algorithmia. And I'll mention that real quick, which is just simply that once you're logged in, there's a data menu option up here at the top. And if I then browse in here, I'll see that I can create collections. And then when I have collections in here, I can actually upload files to them. And then that is a way, basically, for people to go and have their files hosted on our servers where only they can see them. And then I can use those files inside my algorithm. So I would have uploaded, say, my model file here, and then there's a little URL, and I use that in my code to go and load up that model file and then run a prediction on it. So this will tell you how to do that. You basically download the model file, you upload it into your hosted data. You copy the URL, which appears after you upload it. You make a new algorithm. You're going to copy in this really simple sample code that I have here. And this is an example of what a very straightforward prediction algorithm would look like, right? So I'm importing scikit-learn. I'm importing Pillow because that's what I use for my image manipulation, and NumPy, of course. The Algorithmia client instance here inside the algorithm just gives me the ability to manipulate those files. So you can see right here, I go and I load up that file by simply referencing that model URL from the file I just put into my hosted data, and use joblib to load up the model. So now I have a loaded and ready to go scikit-learn model ready for predictions. And from there, it's really, really simple. I just say, go and get the image. And I'm using Smart Image Downloader, so the user's going to have sent in some URL of an image. If that URL is just a straight direct link to the image, great, works out of the box. But this, again, is where the power of having other algorithms out there to lean on really comes in useful. If I went and I looked in Algorithmia and found the description of Smart Image Downloader, I would see it basically describes it. And what it does is if there's, say, a JavaScript wrapper around that image or some kind of wall that prevents me from automatically downloading the image because it's not a direct link, Smart Image Loader basically tries to circumvent that. So if you're using, say, Imager, they've got a little JavaScript wrapper you've got to click through to get to the image. And often users will just cut and paste the Imager URL, which is actually a web page, not the image itself. Well, Smart Downloader is going to take care of that problem for you. You can pass in, say, an Imager URL into this. It's going to find the underlying image and give that back to you. So once I've got that image, I simply open it up, resize it and grayscale it so it's in the format that my model expects, run an actual prediction on that, and then just return it. That's it. What this particular one does is if I give it an image that contains a digit, like a handwritten 1 or 9 or 7, it's going to return 1 or 9 or 7, whatever integer it sees inside that image. So I simply int the result and then return it, and that's it. I don't have to think about anything else. It's just going to be expressed as an API that I can simply cut and paste as demonstrated here. But what I'll be getting back is the value that was inside the image itself. So you can go ahead into that repo. You can try it out on your own time. Again, bit.ly/algodev and then digit recognition. And once again, a reminder that if you do decide to do that, then when you sign up for Algorithmia, use that NEXTCON18 promo code. That's going to put $50 into your account, make it easier for you to run that a whole bunch of times, thousands of times, without ever actually getting charged for it. And with that, we'll move on to questions. Just a few quick notes for you here before I go. Again, that promo code. The Developer Center, if you go to algorithmia.com and you click on the Docs tab, it contains a whole bunch of useful guides. So we've got ones in every single language out there that we support as a client, as well as a whole bunch of framework guides. So going into Docs here, if you're just using Algorithmia to run models, here are all your client guides. If you're hosting your own model, you'll go into algorithm development, and then you can either pick one of the language guides for how to do it, or you can go into our deploy your model section and pick whatever framework you are using. So if, for example, you're using TensorFlow, we have a whole guide on how to make TensorFlow work really well with the system and how to make it fast, etc. There's also lots of recipes, sample apps, and that kind of stuff that you can play with. And once again, if you are interested in a private version of this where you want to do private cloud or on-premise, just get in touch with sales@algorithmia.com.